Okay, welcome to this lesson on parallel lines and their transversals. I have two slides that you'll want to take notes down from or do a screenshot that you can print off. This is slide 1. You can pause the video if you need to. Slide 2. Okay, we're going to find the measure of each angle. First we want to find the measure of angle ECF. So in finding ECF, what I'm trying to get here is this angle right here, ECF. Well, what I know is that this angle here, CBG, and ECF are corresponding angles. So by the corresponding angles postulate, they have to be congruent, meaning that angle ECF has to be 70 degrees. So using the corresponding angles postulate, we've shown that the angle has to be 70 degrees. Now, I want to find the measure of DCE. DCE is this angle right here. So what I can do is realize again with the corresponding angles postulate that it's going to be the same as ABC. These two angles are going to be congruent using the corresponding angles postulate. So what I'm going to do is set 5x equal to 4x plus 22 because those angles are congruent. I can set them equal. So now I'm going to solve for x by subtracting 4x from both sides to get x equals 22. I would then plug back in to the 5x for angle DCE by doing 5 times 22, and that's going to give me that the measure of angle DCE is 110. Now hopefully some of you saw that there was another way that you could do this. So if you look at the fact that angle CBG here is 70 from what we did in part A, and that tells us that because these lines are parallel that ECF is also 70, then we know that this line here DF, made up of the angles DCE and ECF, these two angles form a linear pair. So the two angles have to add up to 180 degrees. So if this is 70, then this other angle, regardless of it having an x in it, has to be 110 degrees because they add up to 180, which was our answer down here. Okay. So a couple different ways that you could get that. Here we want to find the measure of QRS. So we're trying to find this angle right here, QRS. And what we know is that these two lines are parallel. Well, this angle here, 118, is not congruent to QRS because it's on the same side of this transversal, but it's also in the interior. So that makes these two angles consecutive interior angles or same side interior angles. What we know from the consecutive interior angles theorem is that they have to be supplementary. So in other words, this angle right here, QRS, has to add with 118 to equal 180. So that's one method I could use. I could just say this angle plus 118 equals 180, and I could subtract 118 from 180. Another option that I can use here is to say that angle X and the 118 degree angle are corresponding angles, and by the corresponding angles postulate, they have to be congruent. So then I could say that angle X is 118, and that the 118 and angle QRS form a linear pair, and so they have to add up to 180. So either way, at some point I'm using my supplementary rules, whether I'm doing it with consecutive interior angles or using the corresponding angles postulate and then using linear pair postulate to say these have to add up to 180. Either way, I'm going to get 62 degrees for my final answer. Because when I take the 118 away from 180, I get the 62. And again, that can either be from the consecutive interior angles theorem or using the corresponding angles postulate, which is what we've done here on the screen, and then using the linear pair postulate to put these two together. Okay? Now we want to find the measure of angle EDG. So EDG, we're talking about this angle right here. Well, this one's pretty easy to find. It didn't ask me to find x, it asked me to find the measure of the angle. So I just need to know what it measures. Well, look up here at FBC. Because line AC and line GD are parallel, these two angles fall under the alternate exterior angles theorem. They're alternate exterior angles, and therefore they're congruent because the lines are parallel. So angle EDG has to be 75 degrees. Our alternate exterior angles theorem. Now in terms of angle BDG, BDG is this angle, whoops, not that one. BDG is this angle right here. So it's the one marked with the X. So I want to find that angle right there. Now, what I have is not really conducive to finding X quickly. So, but if I go back to what I did in part A, I know that this angle down here is 75 degrees. So what I can do is I can set this angle x minus 30 equal to 75 degrees, using again the alternate exterior angles theorem, that these two angles have to be congruent. And I should mark these separately so we're not confused. So these two angles are congruent with the two arcs. This angle x that I'm looking for with the single arc is a different angle altogether. So the measure of BDG, what I'll do is I'll set as x minus 30, which is GDE, not the angle I'm looking for, but you'll see why this is going to help us in just a second. If I set that equal to 75, then I can solve for x. Well, x is what I'm looking for. So when I solve for x, I'll have the measure of angle BDG. So I'll add 30 to both sides using the addition property, and I'll get that x is 105 degrees. Pretty straightforward calculations there. Okay. Here I want to find the measure of angle ABD. What you need to understand here, it's a little hard to tell in the picture, but the 2x plus 10 is this angle right here, and the 3x minus 15 is this angle right here. Okay. So because these lines are parallel as marked by the red arrows, then I know that these two angles, which would be considered alternate interior angles, have to be congruent by the alternate interior angles theorem. So I'm just going to set the two equal to each other using the alternate interior angles theorem. So 2x plus 10 equals 3x minus 15. Two operations to finish this out. I'm going to be subtracting 2x from both sides, but that puts x's on the right side, so I want to put the numbers on the left side, so I've got to get rid of this minus 15, so I'll add 15 to the other side. So I'm going to subtract 2x to the right, add 15 to the left. So I'm going to use the subtraction property and the addition property to state that 25 is equal to x. Now that I know what x is, if I want to find the measure of ABD, remember that ABD was the one that measures 2x plus 10. I just plug 25 into that equation using substitution. So 2 times 25 is 50 plus 10 gives me a total of 60 degrees for the measure of angle ABD. Alright, and then finally here I want to find x and y in this diagram. Now this is going to be a little tricky for you because what we have are three parallel lines, L, M, and N, and you can ignore one of them at a time. So I'm going to actually compare this angle here, which is the 5x plus 4y, this angle right here. I'm going to compare it to the 55 degree angle. Now here's what I'm going to do in order to do that. I'm going to ignore this entire line here. I'm just going to pretend it's not even there. So all I'm focused on is line N and line L. What I'm looking at then is I have transversal P running through those two lines. This angle, the 5x plus 4y, and this other angle, the 55 degrees, they are on opposite sides of the transversal. 55 is above it, the 5x plus 4y is below it, and they are between the two parallel lines, L and N. That means they are alternate interior angles, and alternate interior angles are congruent. So I'm going to set 5x plus 4y equal to 55 using the alternate interior angles theorem. Now, same idea, but I'm going to have to remove this stuff here. This time, what I'm going to do is I'm going to focus on line N and line M for my second equation. So I'm just going to ignore this line over here. I'm just going to focus on this angle, the 5x plus 5y, and this angle, the 60. Well, you'll notice that both of them are below transversal Q, and they're both left of their respective lines. The 5x plus 5y is left of N, and 60 is left of M. So they are in the same corresponding locations. So using the corresponding angles postulate, I'll set those two equal to each other. So what I now have are two equations and two unknowns, x and y. So from Algebra 1, I'll use my linear combination method. In other words, I'll subtract one equation from the other in order to eliminate one variable, the variable that matches up the 5x. So I'll get rid of the x by subtracting one equation from the other. Here's what it looks like. I'll take the 5x plus 5y equals 60 minus the 5x plus 4y equals 55. Obviously 5x minus 5x, that's going to cancel out. The x's and the 5's, they're gone. 5y plus, and it looks like 5y plus 4y, but remember you're subtracting the entire equation. This minus out here. So this is really 5y minus a positive 4y. 5y minus 4y is y. And this is 60, again, minus the 55. So y is 5. Now that I know that y is 5, what I'm going to do is plug back in to one of the equations, and that way I will be able to solve for x. So I'm going to substitute into 5x plus 5y equals 60, plugging in 5 for y. That's what's listed in red here. 5 times 5 is 25. When I subtract 25 from 60, I get 35, and I'll be left with 5x equals 35. 5 goes into 35 7 times, so x is 7. So I know that x is 7 and y is 5. Pretty straightforward calculations. So what we're doing again today is, remember, if the lines are parallel, then those angles are either congruent or supplementary based on the types of angles they are, the types that we had identified in lesson 3.1. So what I want you to do now is to take this little quiz, bring it with you to class, solving for the measures of the angles, solving for, so you'll have to solve for x in some cases, but your goal, let's make sure we're clear, is we want the unknown angle measures. So I want to know what is the measure of angle 1, what is the measure of angle 2, not what is x. So finding x is part of that, but I need to know what the measure of the actual angle is. Okay? And it's different setup for each problem here, 1, 2, 3, and 4. So just because you found something in one doesn't mean it's the same in the others. All right. Thanks for watching. Have a great day. See you in class. We'll do a couple formative assessments, and the assignment should be good to go.